So this is the Phase Displacement Oscillator from WMD. It's got 4 oscillators with individual outs, various sum outputs and phase control over each of those outputs, along with a triple bipolar VCA, the TB VCA, and the QAAF quad anti-aliasing filter to the right, which are 2 expanders that allow us to use this phase distortion synthesis a little bit more easier than just with the oscillator on its own. So first, let's look at the basic features that we'd get on most oscillators. We've got our output for oscillator 1. We have a channel select on top, and we can see the LED change from the 1 to 4 LEDs. We've got a waveform select. And even though we've left that on a richer wave, channel 2, has a wave select as well, and they're all individually selected waves. Sticking with a sine wave, we've got coarse tuning. We've got fine tune. And then the more standard features are volt per octave for our musical pitch sequence, FM, sync, and then we've got these phase inputs and the various outs. One thing to note is that these expanders are pre-normal to the unit, so if we take our output from output 1 on the filter, and we actually select a richer wave, we'll get this filter in from that quad anti-aliasing filter, and there's a really lovely sort of slow response from this Vactral, a quick whip of the filter. It just takes that little bit of time to respond. It's a really nice sounding filter. All 4 outs are normaled to that filter. And with a sum out. Okay, so let's start looking at this phase distortion synthesis. On the first output, we've just got a wave select and no control of its phase, so we can't modulate anything, we're not getting any new waveforms beyond that waveform select. But if we move to output 2, we can affect the phase of output 2 with the first oscillator. And because this is normaled through to this VCA, each of these levels on the VCA will affect the amount of modulation signal. And as this is a VCA, it's got a CV input, so we can actually modulate that with external voltages as well. But let's just start with static modulation that we can get from turning up each VCA channel. And this is just a basic sine wave on the first oscillator. And again, if we go to the second oscillator, basic sine again. Could change this to a different wave. Some richer sounds. We're going to stick to sines because it's a little bit more easy to see and comprehend what's happening when it's just a really basic waveform to start with. By adjusting this modulation depth, we change the phase on the second oscillator, and we've also got direct access to the oscillator's phase as well, which creates an almost PWM style sound when we're moving that wave. Now if we move to the third output, this is now affected by oscillator 2, but that's being affected by oscillator 1. So if I go back to oscillator 2, turn down the modulation, output 3, get a very similar thing by modulating the third channel's phase by the first channels. But if we now modulate the second channel from the first channel, when we're actually changing the modulation depth between the second oscillator to the third, which is what we're listening to, output 3, this is now already affected, so we're creating this series patch where it's moving one to the other, modulating each other. So the modulation depth on oscillator 2 from channel 1 affects the tone of output 3 when we're modulating output 3's phase from output 2. The same principle holds true on output 4. This will modulate output 4 from output 3. Very similar tone. Leaving this at full, let's modulate the third oscillator, which is statically modulating the fourth from oscillator 2. modulate oscillator 2 from oscillator 1. So let's go back through and add some modulation, and you can hear even just with 4 sine waves this starts to get some really complex, nice, great sounds for sound design. So I'm going to use an envelope that's just been randomly triggered into the CV of the first channel on the VCA, which, if you remember, this is going to affect the amount that output 1 modulates output 2. That's just a static offset. Let's use CV instead. So we've now got this moving phase distortion between that. Going to output 3, when we turn up the modulation, output 2's already now been modulated. So that modulation carries through. Let's actually modulate this as well. Turn the CV up. So this modulation is now all starting to affect each other as it's all running through in series. Going through to the 4th output, all of what you just heard is what will actually modulate the 4th channel. So let's turn up that modulation depth. And notice, because this is phase distortion as opposed to FM, we've got a really nice stable root note, whatever we tune that to. We're not getting this instability and moving of that fundamental pitch. Let's modulate the 4th channel, which is going to change how much of all that other modulation affects the phase of the channel 4. Going to the filter, we'll come out of output 4. All these are normal to the ins. Some nice filter in. There as well. Now, this is a good time to go through the different outs. So the first out is doing nothing. Second out is a second oscillator with its phase modulated or distorted for this phase distortion synthesis from the first oscillator. Output 3 is getting phase distortion from output 2, but if you remember, that's getting modulation from output 1 as well. And output 4 is being modulated by output 3, which has already been modulated by 2 and 1. And the levels of which are being modulated on that VCA. Now the sum output takes a mix of all 4 outs. Very different from what we can consider our final output, which is actually output 4. Because you've got these other tones carrying through. Now the sum normal is again a mix of those waves, but we can actually remove waves by plugging in a cable to take that output. So if I don't want output 4 in this sum normal out, plugging a cable in will remove it. Then plugging a cable into output 3 will remove that. So the sum normal is now a mix of out 1 and 2, because I'm not actually taking anything from those cables. The circuit inside detects whether they're being used. The sum is all 4. And the staircase is quite a nice, unique square-like waveform. There's a stair-stepped waveform, so it looks like a series of square waves all stacked together. This derived from the phase differences between all these oscillators. Now again, this is a nice rich wave. So if we use the staircase as an input to our filter, let's say channel 4, come out of that. Some nice filtering. Let's go back through the outs and actually change these waves. So channel 1, let's change that. Nice wave there, nice solid fundamental with just a few slightly buzzier harmonics. Let's see how this affects the modulation on channel 2. channel 1 so you can hear how the waveform that's modulating channel 2 affects that modulation sound. That's quite a nice sound with a deep fundamental and lots of fizzy harmonics. Now channel 3. Affected by channel 2. Let's go change channel 2's waveform. That's nice, brought out a lot of really throaty mid-tones. Let's add some modulation from the first channel back in. That's full on. And channel 4. Let's change channel 3's wave. Let's change channel 4's wave as well. Go from output 4. It's really full on modulation. Okay, so you're listening to output 2 at the minute, and this has got a pitch sequence going into the volt per octave, and we're going to create a simple little bass synth type line. We can select which waveform we're going to use for output 2. I'm going to stick with that wave because it's a little bit buzzy in some of the harmonics, but it's not really rich and full like a saw or a square. Now turning down my VCA, I can control this with an envelope. This is a basic amp envelope style situation in a synth, with an envelope just opening up the amplitude and the volume per note. Now we can look at modulating this with a phase distortion, and that's in modulating the phase of the second oscillator from the first. So let's turn that up in our VCA. Now if we don't want that static, we can use an envelope. So let's patch the envelope that's next to that VCA into the CV. Turn up the CV depth. So then this envelope and its settings are affecting the depth of modulation. Without now moving the phase and distorting that phase on the second oscillator, let's change the second oscillator's waveform and go down to a sine. Now it works really well on that sine because we can hear that envelope really easily move that phase. Short little envelopes had a nice little click and some punch, great for sub bass. Now we'll go to channel 1, actually move the waveform of channel 1 so it's not a sine wave distorting the phase of oscillator 2, this could be a different waveform. A little bit richer from that triangle. It's really nice sort of hollow, fizzy but yet deep sort of sounds on that wave. We'll stick with that one. And we can mix the standard modulation amount from that VCA's bias, which is just the voltage that's static, with the CV. Turn the CV down, we could just have a set amount. Or a mix of a set amount and some of the envelope modulation. Then moving on to oscillator 3. We can use the bias on the second channel of VCA to turn up the modulation depth from the second oscillator to the third. I'm actually going to add some modulation to this as well. You can hear those harmonics being pulled around. It's still quite a nice soft sound, but that modulation, changing the modulation on the second oscillator by the first, and all of that now modulating the third. Let's change the third channel's waveform. Instead of coming from output 3 there, let's take output 3 from the filter. And use the envelope that's modulating our VCA to control the level to modulate the filter's cutoff. Look at output 4. Pretty clean, except with this modulation starting to kick in. Let's go back and change all these waveforms to be sines. Again, we'll come out of the filter. So you can create some really unique sounds, either using sines, something softer, or some richer waves, and having all of those 4 oscillators modulating each other. So let's look at using this as an LFO, and first let's look at the sound that we've got going on. This big, rich 4-saw wave chord set up between different oscillators in the patch, and this is going to go into a reverb, so it's a quick burst of the dry wet going up. Really lush, thick reverb on that chord. And this is made up of 4 separate parts, and we've got 4 different outs on the PDO, so we can use these as 4 different LFOs. So I'll go through what we're actually listening to. We've first got lowest note, 5th above, and all 4 note, making our sound. Now each one of these is going through a filter. So let's turn the volume of 3 of those down, knock the filter down, and that one. Filter down on that one, filter down on this one, and filter down on this one as well. Now with 4 different filters and 4 different oscillators, we've got this really rich sound. So let's look at actually modulating these together. If I turn them all back up in my mixer, we've got this slightly more muted sound now they're actually being filtered. Let's start with the first oscillator. We can hear that's up at audio rate still, moving the cut-off of this filter. Although we get some nice audio rate modulus, let's drop this down to be an LFO. You can see all 4 LEDs are in phase. We can manually knock these phases out though. So you see we've got in 4 different LFOs. Let's stick them all in time with each other. Modulate the second one from the second LFO, third voice, and the last one. These filters are now all opening up from 4 oscillators, providing 4 different LFOs from the PDO. Now at the minute they're all in phase, so they're not actually that different. We'll start knocking these out of phase. Let's say 90 degrees on one. Turn this down a little bit. Different cascading phases with these different pushes and pulls between the LFOs. Now if we turn our reverb up again, audio rate so we can listen to it. I've put them all back into phase with each other. We actually modulate the phase of some by each other like we have been doing at audio rates. By turning up the depth of modulation between the first oscillator and the second, you can see and hear that this second LED is now starting to move differently to how it was before. If we turn that modulation down, these are all near enough in phase of each other set by these knobs, but we'll modulate that again. It's also giving this sense of like a push and pull in the rate as well as it's sort of swelling up and down. Let's modulate the fourth oscillator. So even when these are in phase there, the modulation is actually knocking these out of phase. So let's actually change that. Turn the rate down slightly. Just to take a bit of the brightness out, I'm going to turn some of the cut-offs down on each filter. Turn the reverb up. And using the syncing, we can hard reset these LFOs as well. So I'm just going to use a random gate from a random module. Turning the reverb down. Let's turn the modulation off. Put these back in phase with each other. So now they're all back playing together. This is what the sync is actually doing. So you can hear there that when this random gate fires, it's resetting these waves. It almost feels like these waveform cycles sort of tripping up over each other. Let's add some modulation again. Turning this down. Knock their phases out. Turn the reverb up. Gone really low with that tuning, so let's just knock this up a little bit. So it makes for a really great LFO module.